We are live. Hi everyone, welcome back to Codera. Today in this video, we'll be discussing the Leetcode daily problem, that is daily challenge for 23rd of January. The name of the problem is Sequential Digits. This is a medium rated problem and I agree to that as well. And this problem has been previously asked in a company like Amazon and might be possible that it might have been asked somewhere else as well. So this is a quite easy problem, but it's the thing is that you just have to apply logic a little bit, right? So you can do this problem using DFS as well as BFS. So we'll be discussing both the approaches, but first before that let me tell you about the problem. So in this you'll be given a particular range, and in that range you have to find the numbers such that they are sequential digits, such that the numbers are having sequential digits. So I'll be letting you know about that as well. So please consider giving me a +1 in the chat if everyone is able to hear my voice and my screen is also visible to everyone, and then within a minute I'll start. Okay, is the problem statement particular range, and is everything clear, right? So in this problem what you'll be given is you'll be given a range that is low and high. This problem previously has been asked in Amazon, right? So this is the problem name is sequential digits. So basically the digits in the particular number, every number that you will be having, they will be sequential. So they are saying that an integer has is said to have sequential digits if and only if each digit in the number is one more than the previous digit, right? What do I mean by that? So if I say that I have digit 1, 2 and 3, or let's say if I have digit, let's say I say that I have number n as 23, right? If I have my n as 23, in that case, if this is the first digit, right, if it's the first digit, then the digit adjacent to it is just one greater than it, right? It is 3. If let's suppose that I had 4, so the digit adjacent to it should have been 5. Let's suppose that this was a 3-digit number, so in that case I should have had 4. With adjacent to 4 I should have had 5 because it is one greater than the current digit. Then after that, with respect to 5, if I had one more digit towards its right, then that should have been 6, right? So this is what a sequential digit means. Basically the difference between the adjacent digits should be 1, so that means that they should be in increasing order, and such that, like, if there is a digit x, so the next digit should be x plus 1, right, is 1 more than the previous digit. So you have to return a sorted list of all the integers in the range low to high, which all the numbers which are having sequential digits, right? You have to return all the numbers in this particular. If let's say I have the range as 1 and 100, like this, or let's say I have the range as 100 to 300, as it has been mentioned in the problem, right? So in this case you can see that they have said that 1 2 3 and 2 3 4 are the only numbers, like 1 2 3 and 2 3 4 are the only two numbers, right? This is one number, this is one number, and this is the second number. These are the only two numbers that are there that will help you out in that are sequential, right, in which the digits are sequential, right? If the problem statement is clear to everybody, please consider giving a quick +1 in the chat, so that I know that up till now the problem statement is clear, and then we'll proceed further, right? Okay, now let's say that if you had another range, so if you had the range, let's say if the range was like 1000 to 13,000, right? So in that case 1 2 3 4 would have been an option because all the digits are increasing sequentially. Then 2 3 4 5, then 3 4 5 6, then 4 5 6 7, then 5 6 7 8, and then 6 7 8 9, and then 1 2 3 4 5, right? 1 2 3 4 5, so that is a 5-digit number, right? So these are the things that you have in this particular problem. Now the thing is that this much part of the problem is clear, right? So you have to return all the numbers which are having sequential digits. The range of low to high Prathamesh, right? So you have the range low as 10 and high as 100, right? So how will you do this? Let's suppose that you have some range. Let's suppose that you have this range only 100 to 300, right? So in this case what we can do is, I will say that first of all, which is the digit that I can have, I can have, let's say, first of all I can say that I'll be starting from these digits, right? 1 2 3 4 5 6 7 8 and 9. These would be the digits to be specific, if I have to make a 2-digit number, let's suppose I have to make a number in the range 10 to 100 like this, right? So in that case 1 and 2 would be an option for me, then 2 3 would be an option because like this particular high Prathamesh. Okay, so this 3 and 4 would be an option, then 4 and 5, 5 and 6, 6 and 7, 7 and 8, 8 and 9, right? And with this I cannot make a number because like it will not make any increasing number like that. Okay, I cannot make 910 or something like that. That will not make an increasing sequence, right? So let's not consider this number. Another thing, if I had to make a 3-digit number, so it would be 1 2 3, that is last digit plus 1. Can you see that I have done what? I've done nothing but last digit plus 1. So this is 2 3 4, this is nothing but 3 4 5, this is 4 5 6, like last digit plus 1. Here the last digit is 6, so 5 6 7, here 6 7 8, here 7 8 9, right? And here you cannot make any digit, right? Things like that. So this is how it's increasing, like 2 3 4 here, then 2 3 4 5 like this. Okay, can you see this? Is the pattern observable to all of you, right? If the pattern is observable, so consider giving me a quick +1 in the chat. So if I have a number, current number is n, then if the current number is n, then what I need to do is to make the next number, to check if the next number is lying in the range or not. First of all, to make the next number, what should I do? I should do n plus n modulo 10, right? This something like this, or to be precise, let's make it like, let's say if I had 123, right? If I have n is equal to 123 and I want to expand it, so what should I do? I should have this last digit, so what, and I should multiply it by 10 as well, right? So this is n, so I'll do n into 10 plus n modulo 10 plus 1 like this. Okay, why? Because this, if I have this particular number, so the last digit, like n mod 10 is the last digit, this would be 4, so 4 plus 1 will give me 5, I know that. And this particular number, since I am increasing one more digit, so that is why it needs to be multiplied by 10. So this will be 2 1 2 3 4, right? 1 2 3 4 and 0, so this would be like 1 2 3 4 and 0, so this would become 1 2 3 4 5, right? Like this. Is this much part clear? I hope that it is clear, right? So for doing this, what I could do is I now know that I have an approach, right? I have an approach. So what I could do is, I know that I have a low range and a high range. Okay, what I could do is I can say that let's have a resultant vector. I have a resultant vector. Let me write a vector itself. So I will have a vector int in which I'll be returning all the resultant numbers, right? After that, what I could do is I will first of all have a queue, right? I'll make a queue. Why making a queue? I'll let you know. I'll let you know in a while. Okay, like a Bfs approach would work. What I'll do is I'll start my I from 1. I is lesser equal to 9, I plus plus, and in my queue I'll push all the numbers, that is all the digits 1 to 9. Okay, I'll push 1 2 3 4 5 6 7 8 and 9 in my queue like this. Okay, they will be arranged in this particular fashion. Let me, to be precise, let me write it here so that I can have some space. 1 2, okay, right? So I'll have 1, I'll have 2, I'll have 3 4 5 6 7 8 9 like this. Okay, they will be there in the queue, they will be present in the queue, right? Like this they would be present. Perfect. Now once I have these numbers, so what I have to do is, until my queue is empty, so while not of queue.empty, just applying a simple Bfs approach, what I can do here, I'll have the current element, right? Current number, let's say the current number is n, let's mark it as n. So if I have the current number n, then n is equal to what? N is equal to q.front. So I'll take out the front element. So initially I'll take out 1, n is equal to 1 for me, and what I will do is I'll pop out this particular number. So I'll say q.pop. So that means I have popped out this particular 1 from my queue. After this, what I will do? What will I do? Anyone would like to suggest what I can do? I will check that if this particular number, I'll check if my n is greater equal to my lower range and n is lesser equal to higher range. So n is lying in the range inclusive in the range low to high, that has been given to me. If n is the number that lies in the range, then I'll simply push it into my resultant vector, right? I'll say result.pushback. That is in the vector m, right? Now the thing is, how do I make the next number, right? The thing is that how do I make the next number? So for doing this, what I am saying is, if I have a number n, hi Aryan, if I have a number n, then how do I make, like if I have 1, I need to make 1, 2, right, like this. If I have 1, so I need to make 12. So what I'll do is, I'll extract the last digit out. So what I'll say is that, what is the last digit? N mod 10 gives me here 1. So I'll have 1. What I will do is, I have the last digit, that is n mod 10, okay, and I'll add 1 to it, so that this becomes 2. And then the current number I multiplied by 10 and add it with the last digit plus 1. So that will become what? 1 0, that is 10 plus 1 plus 1. So that is nothing but 12, right? So I'll have 12. And what I'll say is that if my I also, in the initial part, you can notice that if my number mod 10 is lesser equal to 8, if it is lesser equal to 8, because if the last digit is 9, like if I am adding 9 to the end, that is perfect, but I should never add a 10, I should never add a digit 10, right? So that is why I will check it till 8. If the last digit is lesser equal to 8, in that case I'll be adding 9, because I am doing n mod 10 plus 1, so that is 9, but I will never add a 10 because 10 is not the last digit, right? Yeah, perfect. You are saying perfect. Next number will be this, but you need to keep a check on this particular situation, right? If you want, I can just show you up a little bit. Let me show you this part. Let me show you what I am saying. I said that if the last digit was 8, then I made 789. But if the last digit was 9, then I did not make any digit here, right? I could not make any 3 digit with respect to this 89. With respect to 89, I could not make any last digit. Like with respect to this 9, I could not make any last digit because the last digit was 9, and if I add 1 to it, so that would not help me, right? Similarly for this, that if I have here, so if the last digit is 9 here, so I would not have a digit just below it, 4 digit number. So and here I will have 6, 7, 8 and 9 like this, okay? So this is what I'm trying to explain. That is why we have the condition, that is n is lesser than equal to 9, right? Now this much part must be clear, I hope. The next thing that we have to see is, that what will you do with this number? So you will simply push it into your queue. You will push this particular number, that is n into 10 plus n mod 10 plus 1. You will push it into your queue, and then you will keep on running your while loop like this. And whatever numbers are there, which are in the range, whatever is the value of n, the numbers which are in this range, that is low to high, they will get stored in your resultant vector, and in the end you just simply return your resultant vector, right? So this is a linear approach. Let me show you the code part for this BFS approach that I am trying to tell you. What I would be doing basically is, I have a queue, right? Why I am making a queue? In this I do not need to even sort it. Why? As I told you that you will have the numbers one by one, like I told you here, right? That if you have 1, right, so 1 will make 1 2, 1 will make 1 2, right, for you. Then after that, what will happen? 1 will store 1 2 for you. So let's say 1 2 was like I was finding, let's say in the range 1 to 100, right? If I am finding in the range 1 to 100, let's say I'm finding in the range 1 to 100. So what would happen? Initially I have the first number as 1. I'm trying to do a dry run on if can we push 1 to 8 only? Yes, you can push 1 to 8 also. That will also work, but just to give you an intuition, right? Like it's better to push 1 to 8 also, but even if you push 9, so that will not matter because you are always checking n is lesser, the last digit is lesser equal to 8, right? So if I have the current number is 1, so what I'll do, I'll make 12 out of it. I'll make 12. So what is my queue? Queue is having 2, 3, 4, 5, 6, 7, 8 and 9 like this. And in my resultant vector, what do I have? In my resultant vector, I'll have first of all 12, right? After that, my 1 has been popped out. So now I pick out 2, I pop out 2 and I make from it 23. So what will happen? Like this 12 will be there and 23 will be there. I have not pushed them back into my vector. Now I have 3. So with 3 I'll make what? With 3 I'll make 34. With 4 I'll make 45. With 5 I'll make 56, right? And with 6 I'm not pushing currently anything in my vector. So with 6 I'll make 67. With 7 I'll make 78. With 8 I'll make 89, and with 9 I'll make nothing, right? So after this will be my current start n, right? The front element of the queue would be this. So I pop this out and I see that this is lying in the range, so I'll put it into my vector, right? I'll put 12 into my vector. Then similarly I'll pop this out and I'll have what? I'll have 1 2 3, right? I'll make these digits. Okay, so if you are greater than high, so you can also break. Now if I have this number 23, so I'll see that whether it's lying in the range. Yes, it is lying, so I'll push it and then I'll pop it and I'll push the number 2 3 4 like this. Okay, so whenever the current number, like I'll be pushing 1 2 3, then I'll be pushing 2 3 4 like this. So this is how it will be working, right? Is this much part clear to everyone? Is this much part clear to everybody? Okay, now the thing is that is there any other alternate approach? Like, let me show you the code part for BFS. First of all, what I was doing is I am starting from 1 to 9 and I push 1 to 9, then until my queue is empty I am just running it, and the number I get, if that is lying in the range, so I push back. Otherwise, if the last digit is lesser or equal to 8, so I will make the next digit. So that will be nothing but q.push n into 10 plus n mod 10 plus 1 like this, and in the end I'm simply returning the result. So if it happens that if you can say, you can apply break condition as well, that if my number is greater than the higher range, right? So in that case I can break from this particular you can say what, I can break from this particular BFS traversal, right? Now this much part is okay, right? So for doing this, it will take order of n time, a linear time, that is the number of the number of maximum number that you'll have, order of n time like this. But can we do it otherwise? Yes, we can also apply a Dfs approach for this particular thing. What I can do is, let's say I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, 7, 8 and 9, things like these. I have numbers like this. So for each particular number, what I would be doing is, for each particular number I can call a particular DFS call, right? Instead of going in the breadthwise order, I could go in a depth order as well. Now the thing is that what I can do is, I can have this particular number, let's suppose this is my current number. So what I'll do, again I'll call a breadth first, so that means the current number into 10. So I'll say that n is my current number is 1 into 10, so that will gives me 10 plus the last digit plus 1, so that will give me 2. So I'll have 12 instead, right? I'll have 12. And let's suppose I want to make one more number. Let's suppose that I wanted to make till the range 1000, right? This, okay? So I'll have 1 2 3, then I'll make one more number, that is 1 2 3 4, 1 2 3 4, right? So can I make 1 2 3 4? No, that is not needed because it is not lying in this range. So I'll simply return from this particular BFS call like this, DFS call, sorry. So I'll move back to here and then here, and then the BFS will start for 2. I'll check for the DFS order traversal would start for 2. So for 2, what I'll do, I have to check all the numbers which are lying in the range 1 to let's say 1 to 1000, right? That are lying in the range 1 to 1000 at that time saying. So what I'll do is, I'll see 2 lies in the range, yes 2 lies, so I'll push it back into my queue. After that I'll build the next number, so that is 23 with the next DFS call. So I'll say okay, I can build it. Now what will happen, like this will get stored like this. Let me write the current resultant vector, how the vector would look like. So this, let's suppose that this is my resultant vector. So resultant vector would look something like this: 1 1 2, then 1 2 3, then I'll have 23, and then after I'll have 1 3 2 1 2 3 4, then 2 3 4 5 would be greater than the higher range, so that is why I'll not be having it in the range, and I'll backtrack, I'll move back from here. Okay, so I move to the next digit. So this would be 2, then 23, then 2 3 4 like this. Then I'll have 3, with 3 I'll have 34, and I can also make 3 4 5, but I cannot make 3 4 5 6. So at that moment I'll return. So simply these are the 3 numbers that I'll be inserting one by one: 3 34 and then 3 4 5 like this. Okay, is this part clear to everybody? I know I'm taking some time, but still that's better to understand. Okay, now I'll have 4, so I'll call the DFS for 4. So I'll push back 4 because 4 is lying in the range. So what I'll do, I'll push back 4 in the vector. After that I'll make the number 4 5, because last digit plus 1, as I told you, the current number into 10 plus last digit plus 1. That is how you'll be making. So number into 10 plus n mod number into 10 plus number mod 10 plus 1 like this. Okay, so I'll have 45, right? After that I'll have 4 5 6 like this. So I'll write 4, then I'll write 4 5 6. I'll also now the number would go to 4 5 6 7. So since this is greater than high, so that's why I'll return simply from this particular DFS call, and then I come back here. So I have 5, so 5 is lying in the range 1 to 1000, so I'll write 5 in my range as well, right? Like this. I'll have 5, Then let's say the next number I'll make is 56, so I'll add 56 as well, it's lying in the range. Then the next number would be 567, so I'll write 567 in the range as well. Then the next number would be 5678, it's not lying in the range 1 to 1000, so that's why I'll return from this particular BFS call. After that I'll come back, then 6, I'll push back 6 because it's lying in the range. After that I'll have 67, so I'll add 67 as well. Thanks a lot, Shreya. Have you understood this problem, Shreya? Is the DFS and the BFS approach, are both the approaches clear to you? Then I'll have 6, 7 and 8 like this, so I'll add 6, 7, 8. Then if I have 6, 7, 8, 9, so this is greater than 1000, so that's why I'll immediately return from this particular BFS call. And what I'll do, I'll come back, so there's 7, so I'll put 7 because 7 is lying in the range 1 to 1000. Then I'll put 78 as well, so 78 would be there. Then after that what would happen, 789, so 789 is also lying in this particular range, so that's why I'll also put 789 in the range, right? So I'll say okay, 789 is also lying in the range. Now my last digit is not 9, so that is why if I do this, if the last digit is 9, so I cannot move greater than 9, the last digit, so that's why I'll not do anything with this digit, right? I is greater than 9, the last digit is equal to 9, so that's why I cannot make any other number. Next up I'll add 8 into my answer, right, like this. Then what will happen, I'll have 89 in my answer. And with 89, since the last digit is 9, so I cannot have any greater digit greater than 9, right? There is no digit greater than 9, so that's why I'll be moving back, right? These are the two conditions. What are the two conditions? Either my I can say last digit, I'll be writing this two conditions that I'll be writing. I'll be telling you 89, then after that I'll push 9, and with 9 I cannot make any number, as I told you. So this is also one of the approaches. Basically what I've done is I've done a DFS approach. Now you can see that this array that I'm getting is not sorted, right? This particular whole array that I'm getting is not sorted. So what I will simply do is I'll sort it. So if suppose there are n numbers in that range, so it will take n log of n time complexity using a DFS approach, because with DFS you produce all these particular, with DFS or recursion you can say, you produce all the particular numbers that you want, but still you need to sort them because they will not be in the sorted order because you are going depth wise first, right? So that's why it will be there. If this much part is clear, consider giving a quick +1 in the chat, right? Okay, I hope that this much part is clear to everyone, right? Now next up, what I'm saying is, what are the two conditions that I'll be coming back from the DFS, right? Let's say I'm doing what I'm calling the DFS for the low range, or let's say I'm calling the DFS for the I, okay? For the I, that let's say mod for I starts from what? 1, I is lesser equal to 9, let's say I plus plus, something like this I'm doing. Then I'm passing I in this, I'm passing the low number, I'm passing the high range, okay? And what I'm doing, I am currently, the number would be 0, right? Currently the number would be 0, so I'm passing 0 with it, right? Thanks a lot, Chirag, right? So what I'm doing in this DFS function, like I'll make a DFS function. What I'll have is I'll have I, I'll have low, I'll have high, I'll have number in it, right? So what I'll do is, what I'll do with this, can anyone tell me what I'll do with this particular function in the chat? Like when are the situations when I would be returning? So there will be few situations, right? So if my current number that I am having, if it is greater equal to low and it's lesser equal, if the number is lesser equal to high, so if it is lying in the range, then I'll say okay, let's push back into my result. So I'll say result dot pushback or result dot add, whether you are using a list in Java or vector in C++. So I'll add this particular num into my answer, right? And what if, when are the situations when I'll be moving back? Let me just move this particular thing down a little bit, okay? Like this, right? So what I'll be doing is, when are the situations when I'll be returning back? If my number is greater than my higher range, in that case I would return, right? In that case I was returning. If let's say the range was 1000 and I was making 1 2 3 4 5, so this is greater, so that at that moment I'll not call any further DFS calls for the particular DFS call, and I'll return. Or I can say that what I'll do, if my last digit, that is number modulo 10, if it is equal to 9, right? It is equal to 9, or you can say greater than 9 or something like that, then in that case also I'll return, right? I'll say this, I'll return in that case also, right? If the last number, if the number that I am having, if the I that I am having, you can say, or you can say it like this, if the I that I am having, if the I is greater than 9, so if the I becomes 10, then in that case there is not a single digit 10. 10 is a number in itself, like last digit is 9, right? So that's why I'll simply return. And what I would do is, like I'm still calling the DFS before ending this particular thing. So I'll call the DFS for the low, I'll call the DFS for the high, I'll increment my I by I plus 1, right? And what I'll do next, I'll simply say that, okay, now my number would be nothing but number into 10 plus I, like this. Okay, like if you have 1, so if you have in the num you have passed 0, so that is why first of all you will be bending 1 and things like that. Okay, so that is the current number into 10 plus I, that is what I told you. So this is the way that you will be doing it. Like if you have I is equal to 1, and like if you have I is equal to 1 and your num is equal to 0, so in that case you will be first of all making the number 1. Then let's suppose if your I was 2 and num was 1, so in that case you will be making 1 to 12, like this. So that means number would be 1, right? So 1 into 10 would be 10, plus 1 into 10 would be 10, and plus 2, so that will give us 12. Like this you will be making the numbers. So for this, as I told you, that you will also need a sorting approach, right? So for this particular approach, what the thing is that you will be calling a DFS. So in that order of n time you will be storing all these, but you will also need to sort the resultant vectors. So that is why overall time complexity would be order of n log n. Let me show you the code part for the DFS that I am writing. All these codes are also available in the chat as well. Okay, if up till now everything is clear to Shreya, Chirag and others, you can just let me know in the chat, right? What I'm doing, I'm just inserting, first of all I'm calling DFS call every time for ith number, right? For every digit, right? As I told you in the dry run. You can just have a look if you have missed it, right? So if for the ith number I'm calling for the DFS, so I'm passing low, high, in num. So if my number is in this particular range, so I'm pushing it into my resultant vector. And what I'm doing, if the number is greater than higher range, so in that case I'm going back. Or if my last digit is greater than 9, so that means I do not have any further digits left. So in that case also I'm returning from this particular DFS call. Otherwise I'm trying to generate a number, so I'm increasing my next digit by 1. So if initially I had 1, so the next digit would be 2. If my I was 2, then the next digit would be 3, things like that. And I also need to make the number. So number is nothing but number into 10 plus 1. Here you don't need to worry about that, because initially you're passing 0. Okay, so that's how I'm building the number. So basically, first of all 2 will get built, then 23 would get built, right? This, then 22, 3, 4, then 2, 3, 4, 5, things like that. Okay, so for this also you need to sort, because the numbers won't be in a sorted order. So that's why you'll take n log n time complexity overall. So you can see that the problem will get submitted from both the approaches. Let me submit this problem. So you can see that this problem just got accepted, right? So this was the problem of the LeetCode daily challenge for today, and this problem was primarily asked in a company like Amazon. It can be asked at other places as well. So if you are someone who is trying to do these things, so try to solve the LeetCode daily challenge every day. Okay, and if you are still here till the end, so you can make sure to subscribe the channel that we have, Codera, and you can like the video if you like my explanation. I tried to explain it in the best way possible that I could. I did this using BFS, which was a linear approach, and I told you using a DFS approach as well. I did a dry run for both. So DFS approach was order of n log n. Why? Order of n log s plus order of n. Why order of n log n? Because the numbers that you are getting in the vector, they would not be in the sorted order. So that's why in the end you need to sort them. Because they want the answer in the sorted order, right? Like, share, subscribe, and that's it from my side for today. And let's meet tomorrow with the new problem of the day. Till then, keep coding, and thanks a lot.